This conference will now be recorded.
Okay, the recording started and then sharing screen. All right, so today we'll take up the topic. This is the start of inventory planning for IBP. Uh, so till now, what we have seen is the demand planning side. So logically, you can just understand whatever is the output of the demand will become the input for the inventory here, and then whatever the output that is coming up from inventory will become the input for the supply. So what we do is, for example, we have got the demand plan output. We can copy it um, to a key figure called as IO related key figure, IO demand forecast. So that will form as an input. It will help the algorithm for the IO to calculate the required output. So there are several stocks. When we talk about the output of the inventory optimization, this IO, you can just understand it as inventory optimization. So one of the important output of the inventory module will be the recommended safety stock, right? So why do we need the safety stock? Because there is uncertainty in the demand. So there are various factors, right, which are available in the supply chain, which actually, uh, you know, drive, uh, for example, the uncertainty, right? There could be long lead times that are taken up by the planners, by the suppliers or vendors. Because of the lead times are little long in length, right? The number of days to deliver some item, some kind of raw materials, let's say, is delayed, is taking more time, the lead time is more. So it means that the finished good will also have an impact to build, and that's why we should build some kind of safety stock in the warehouse. Another thing could be, right, if we have a make to stock kind of scenario where forecast is our uh, you know driving parameter for, let's say, for the planning purpose, right? So that forecast engine, let's say that forecast is just an estimation, right? So it might not be the accurate results it might be providing. So that's why also we need the recommended safety stock, so to keep some buffer so that we can uh, you know adjust with the demand. So we'll see this portion now. The middle one is our topic. So now you can understand that if there is if we have a warehouse. Now you think from the owner's perspective. You are owning a warehouse. Would you like to just overstock it? The stock is just lying in the warehouse and the sales is not that much. So it means that you have taken that big warehouse on rent. You are paying it, uh, you know, as per square feet, the maintenance charges, right, which you are occupying on rent. Then unnecessarily you will end up in high inventory cost, right? Or let's say that it is under stock. For example, your customers orders are not getting fulfilled as per their required quantity that is there. So then also, that's not the ideal situation. Okay, good. So what is the objective of the inventory planning? That we should have the right inventory, means whatever the quantity has been asked by the customer, and also at the right place. So now let's assume that right quantity is there, whatever the customer is asking, but it is too far. It is not even at the uh, uh, central distribution center, where it will be distributed to the local distribution centers and the customers can take it from there. It is still in the manufacturing plant, and the distance between the manufacturing plant to the local distribution center is the lead time is a lot. Therefore we do have the right inventory built up, but it is at the wrong place. So then also, the uh, the situation is not good. So today the challenge is, there are several challenges within the supply chain because of increasing, competition, increase of the lead times, um, and there are several other factors as well which are not in humans' hand. There may be some climatic conditions or some such situations which are not under the control. Let's say that there is some kind of protest is going on, and then the vehicles are not moving, the transport department, everything is jam packed. So then the goods which are in transit will definitely delay. So lead time unexpectedly will become little more longer by x hours or x days, right? So we cannot predict. So therefore we have such softwares, uh, like which manages the inventory. So there are many softwares which are focused on the supply algorithms, right? So JDA has, and then now some more are coming, like O9 gives very focused solutions for the supply chain. And SAP is also one of the key player in the market for supply chain, right? So what are they doing? They are just helping to improve, to plan, to analyze, and to collaborate. Collaboration for whom? Collaboration for the different stakeholders which are involved in that supply chain. So there will be the planners, there will be suppliers, vendors, right? And there will be several entities like distribution centers, as a supply chain entities. You have customers locations, regional distribution centers, warehouses, regional warehouses, central warehouses, all those stuff, external partners, internal partners, all those, right? So all of them has to um, collaborate with each other, plan, and then improvise this overall solution, so that uh, you know so that the um, so that the risk which are there in the supply chain can be reduced. The uncertainties can be minimized to a certain level. So we cannot say that they will become zero, because it can't happen in real time situation, but they should be minimized, and or the supply chain problems could be optimized, right? So there are set of algorithms which help to achieve such kind of targets. So this is what, so there are few questions which these algorithms will try to answer, right? So the questions can be like, how much inventory do you need at your manufacturing location? How much of that do you need at your distribution location? How much you should be giving it to the customer, because there will be um, some customers which are uh, you know which are important customers, so you want to prioritize them, right? All those kind of things. And these are several factors like lead time, the uncertainties, the service levels that you have, right? In how much time that you will be, and how much percentage of the order that you are fulfilling, right? So under forecasting or over forecasting, that is known as the bias. So if someone asks you what is forecast bias, so it's a tendency to measure, you know, whether it's an under forecasting or it's an over forecasting, right? So if there is a demand of 100 and forecast is coming up as 1000, so it is over forecasting, right? It is 10 times. If the forecast shows as 120 or 125, right, or 115, then it is near that real time demand what we have. Or if the demand is 100 but forecast has been calculated for 35, then it becomes as under forecasting, right? So these kind of things are nothing but these are the important KPIs. Like, people will calculate um, the forecast accuracy and the forecast bias percentage for each time period. Let's say for 1 year, let's say month wise, what exactly is the percentage of forecast accuracy? What is the percentage of um, forecast error that is happening, right? Or what is that forecast bias which is coming up, right? So you will apply the standard formulas into that to come up with the forecast accuracy or forecast bias, right? All that. So if you have a very sporadic demand as well, so sometimes it increases so much, and then sometimes it's becoming very nil, and sometimes it's too low, right? So all those are the factors which, so there are machine learning algorithms also coming up to just realize these patterns in the past, how the behavior is, and then also taking up some other factors like which are unpredictable also into consideration, and then coming up with the with the parameters as the recommended safety stock. So just a quick check, guys. You hear me well? The speed is fine. You're able to follow up?
Yes.
Yeah, yeah, I am able to follow up. Yeah, pretty much I
Okay.
didn't know about it. So,
Okay,
yeah,
okay.
we can
Yeah,
follow up.
yeah. This is good. Yeah. So now you see in the real, real supply chain world, you will have a very complex, supply chain. That's why, whenever this complexity is increasing, so you will come up with, uh, you will take the help of such algorithms, and then you will come up with the recommended safety stock. So IBP has, multi-echelon, you can say, inventory optimization. This one is popularly, it is popularly known as the multi-echelon inventory optimization, which is not going through each and every, stage by stage. I mean, single stage by stage, but it is looking inventory target holistically. So what is its objective? Its objective is to, to meet the service levels, the target service level, right? So target service levels we want to keep as much as high it is possible. It means that we want to achieve 95% or even 96%, or sometimes I have seen in projects they will keep as, um, around 97% of target service level, in order to calculate uh, the output of the inventory planning, the safety stocks and all, right? So also there is an option of, single stage calculation. um, when it is single stage, all these are working in isolation, all these nodes. For example, it's a warehouse or a stocking node or distribution centers, right? All these are working in silos. And the problem here is that if they are working in silos, they are very much disconnected, and there is a possibility of just accumulating the stock, which may result in overbuffering, right? So that could be one of the problem. So what IO is able to achieve with the help of such algorithms, it will manage the uncertainty in the supply chain by determining the amount of safety stock that is required at each of these, stocking locations which are there. So this, you will see that there are various kind of stocks that are there. When we talk about um, this inventory optimization, so there are several drivers also which are, driving this safety stock. So for example, um, we have a demand forecast, right? So we have seen that the output of the demand is getting copied into IO demand forecast, right? So that IO demand forecast is one, input parameter, um, that will drive the safety stock. So, and the forecast error will define your uncertainty, right? So there is something called as, demand forecast error, CV, coefficient of variation for IO. So and then what is your frequency, to order um, the goods? So that is nothing but that is this review frequency. It is known as the PBR. So that's the period between the reviews. And then you have the target service levels, right? And then you also have the lot sizes and all, which is impacting your, cycle stock as well. So if you talk majorly about the lead times, the goods which are in transit and that is getting impacted. So that is also one of the factor which will also impact your pipeline stock, right? Which is still on the way but not yet delivered. It is still in pipeline, right? So there are various factors which will, you know, um, which will define your variability in terms of, so all these are interconnected. For example, your forecast error is increasing, then it means that your uncertainty is increasing, right? Demand is very, very uncertain. It can come up in a big bundle at one particular time, and or during the other quarter it may go so low that you cannot even predict. So it means that the forecast error, maybe forecast you would have calculated as constant, so the forecast error will increase in that case, right? The coefficient of variation, forecast error CV, will increase. So then you have to, in that case, your safety stock recommendation will also become high because uncertainty is more, right? So demand variability is more. And we'll also see, there are different kind of demand variabilities as well, um, that we will see. So you can understand it in this way.
Yeah, I just wanted to see that chart. What does it mean? I'm trying to understand it.
Yeah,
Raw material process, common distributions, then purpose total minimum contribuble pipeline cycle safety. Yeah, that's quite important. Okay.
yeah. So this is all, kind of safety stock. And then this is like, you know from the distribution perspective, location from means, um, let's say from your vendor location, this is being supplied, then how much is the lead time, all that perspective, so you are seeing that inventory optimization from different angles, right? So there is a postponement of it. It means that your lead time is becoming more. There are raw materials which has not reached to you, right? So what will be the impact of these onto your stocks, right? So in that case, whenever there is lead time more, then your safety stock has to be more, right? Because it is taking more time for the raw materials to reach at your warehouse. So all these are interconnected, right? So if we try to understand overall, so let's say that this is customer service level, right? It is in this direction, and
So
you
what
have
you are
the,
saying is the safety stock applies to raw material in process, post-part, like safety cycle pipeline, pre-build minimum required, all have relationship relations the relationship to the location and form, right? Every single one of them,
yeah,
right?
these are independent stocks, right? So all have their different meanings. So safety stock is one of the, recommended safety stock is one of the important output that comes up, but there are several other
Safety stock
stops
applies
as
to
well.
only the safety stock. Here we're only talking about the finished product, correct? I mean, the
uh,
inventory will talk about only the finished product.
you can also, no, you can also, calculate the safety stock for even the semi-finished goods as well, or the raw components as well. So that's not a problem.
Okay.
Even the components that are there, so let's say that there is a bomb, right? So in that bomb, in order to produce, there are several components. So for those components as well, you will be able to plan your safety stock or cycle stock or pipeline. So let's say that, you have the customer service level, right? So the more customer service level, let's say that this is starting from uh, let's say 70%, and then it is going till 100%. So the more you have your customer service level, the more inventory you have to keep. The amount of stock will increase with the increase of customer service level that you have committed, right? So if the customer service level is somewhere around 99%, then definitely your stock levels in your warehouse also has to be high, right? You need to keep more safety stock. So if there are pretty, in 85, so it will be little less, but still you have to keep it high, right? So there is a relation between the the inventory stock, which is directly related to your dollars, right? Your investment that you are doing and you are investing, right? So your customer service level is directly related to your inventory, right? The more you keep the target service level or customer service level, you will find that your inventory has to be more, right? So this is a kind of curve which will be, you will observe it, which will be low for 70, 75, but when you are reaching toward 99 or 98, uh, it will become very high. Then your cost goes very high. So your on-hand stock is, let's say, your cycle and your um, safety stock, right? Your cycle stock and the safety stock. So let's say that this is your on-hand stock that you need to keep it high in your inventory. Yeah, so this is what, this is one of the um, algorithm that we spoke about. One is single stage and one is multi-echelon, inventory optimization. This will help you uh, to do some kind of what if analysis. So, for example, what if I increase my, let's say, PBR, right? Period between the reviews. What will be the impact on safety stock, right? If I just increase some of the parameters or just decrease some of the parameters which are, impacting, which are the drivers for my, driving the stock, safety stock, then how the situation will look like. um, it will help to do all such kind of scenario build up and to come up with the main output of the in transit stock and pipeline stock, cycle stock, all that stuff at the desired level, detailed level of the uh, at the product location level, right? And we can then, definitely put all this data into the charts as we have learned and visualize them in, different type of charts that we have. And um, or we can also set up some kind of alerts, right? Which will alert us if the safety stock goes beyond a certain limit. Let's say that uh, we can generate a alert because that is directly impacting my warehouse cost, right? Maybe it is a situation of over buffering that I may not need so much of safety stock. I already have to consume the previous one. So it will just, I can set up those kind of alerts very easily, which we saw yesterday. with the help of those apps, and then uh, help the planners to do the planning in the efficient way, right? So these are some of the inputs that we give, that what will be the target service level. So you are talking about that 70% to 97%, so that um, we need to give in order to define my target service level of 95%. How much safety stock, for example, I have to keep, and what kind of errors are there in my forecast, as we were discussing. All those will be the inputs, and then this kind of stuff will be the output. And we can also do some kind of simulations. For example, um, simulations like, if I just uh, decrease my target service level to 90% from 95%, I make it 90%, then how much safety stock I have to maintain, and maybe then I can evaluate, right, my financial plan, that how much cost I'm decreasing by just compromising on 5% of the target service level. So things like scenarios like that I can build up, and then I can just play around with it. So before we go to the demo, I just want to make sure that at least um, the concept and all, uh, whatever we have discussed, is it understandable, all that stuff. So guys, what we basically do is, this is also one of the important stuff that we have seen. So let me go to the IBP system. So earlier we have learned about the copy operators, right? So this will again play an important role. So as we have seen that, for example, this. So what will happen is, in the real time there will be some batch jobs where you will see there will be some regular copy operators that will be running to copy, from one key figure to another key figure. For example, this is the demand related key figure, and we want to push this data to the another key figure which is IO related, so that this um, can be utilized by the standard algorithms. So let's say the standard IO algorithm understands the IO demand forecast key figure, then it will be helpful. um, uh, Using the copy operator, we do this copy from one key figure to another key figure. So just to refresh that, we when we studied about this copy operator, so let me go to this. So there are some copy operators which are the standard one which got copied. So here you see that, for example, it is copying the um, final demand to the demand forecast which is IO related. So like this, we can build our own copy operators and then copy the data from one to another, right? So for example, if I just open this, then it will have the source key figure and the target key figure, and for what time period I want to copy the data from source to target, all that. For example, this is my source key figure, right? I can just change it according to my requirement, the source key figure and then target key figure. This is exactly the target key figure where we copy that data, and at what level we need to copy, it will be taken automatically. And what will be the copy level week wise. So one week data. So let's say from 2022 to 2024, it should copy, which is the 130 weeks. And then if you want, we can give some filters while executing that for which period we want to copy this data, right? So like this, we'll have the data in your IO demand forecast. So let's see that. If I go to the new view without template, so I'll take product and then location, and that was the demand forecast. This is the one. And what exactly is my error rate? This is also, as we have seen, that one of the input that that we usually have. Okay, so this is heading 1. This is 2. This is 3. So let me also add this as a favorite. I went to favorite and then I'm giving some name.
So now we are looking at only the demand, correct? Not in the inventory yet.
No, yeah, these are the input parameters, which is the demand, and we can just name it as input. So similarly, what you can
Oh,
do
okay. You are
is
giving
for
input demand, then it will create the projected inventory, correct? For those demands.
yeah,
Uh,
yeah. So yeah, so this is your you know inventory parameters. We can also look at the recommended safety stock, that cycle. So what I'll do is I will just copy this sheet and we can name it as output. So here we can take those ones as the output of these, right? So we have the uh, recommended safety stock, and then we have cycle stock. So all this cycle stock target, you have the pipeline stock, right? So what basically is your cycle stock, and what basically is your this mm, your pipeline, and then another one is the cycle stock, right? So cycle stock, you can understand, you know, whatever current demand you have, in order to meet the current demand until your next order is placed, right? So this cycle stock is mainly, based on your, uh, let's say, your PBR, right? Next order is placed between, so that is nothing but your ordering frequency, right? So which is your PBR, period between the reviews, right? Pipeline stock is something which is your, your recommended safe, which is your in transit stock, right? So, for example, that is still in the pipeline, that has not reached, but it will reach as per its lead time, right? And if you want to cover your, excess demand, or to, to cover your regular demand, even you may, you may keep some safety stock. So what exactly, the difficulty comes here is the complexity increases because uh, there will be the demand variability, the lead time uncertainty. So these could,
But I
alter
think
the,
the
yeah.
recommended safety stock is basically keyed by the planners, or right, or it is calculated by algorithms.
Yeah, so mainly it will be, the planners can calculate it using their formulas, but if they are using IBP, so they can use the IBP algorithms. The, the people are generally calculating it using the multi-echelon inventory optimization. They
Mhm.
execute it over their, product locations. Let's say that they will bifurcate, right? That ABC, you remember ABC categories. So let's say for the A category, which is the high revenue generating, they may, run this exercise uh, of generating the safety stock via the algorithms. Then planners can just go and then review it, right? The recommended safety stock, and if they have some inputs, definitely they can, they can change the numbers here and there a little bit. But from the scratch, I'm not seeing yet, right? They will just give the numbers from the scratch. They will just see what exactly is the output has been given by the system as an output of the multi-echelon inventory optimization. Then there, if they just want to play with the numbers, how they will play? They will play with the help of the scenarios. So
Help
they
of
will,
what? Sorry.
scenarios. So this
Scenarios.
scenarios, yeah, this you can create the scenarios. So we'll see all this as a part of our demo when we are doing it. So we'll see that, we'll create the scenarios, and uh, we will take different, uh, we'll change the parameters and see that, if we change it, how does it looks like, and if we would not have changed it, how would have been the situation of the safety stock, right? So we'll discuss all that stuff, in our upcoming demo sessions, right? So this is how you can just see the output and then input of this. So let me just save this favorite first. I think it is already saved. Let me update it.
So it is basically taking the, so when they go the first time to go live, so first they run the demand and then the recommended safety stock will either demand the consensus demand forecast and then it will generate the recommended safety stock, or it will use the existing inventory. I mean, I don't know. Or is the existing inventory and then they key all this existing inventory by location and
Now,
product.
see, yeah. See, the inventory that you are getting, right, from your execution system, right,
Mhm,
is
mhm.
right. So what you are calculating here is for your future ones, right, as a part of your planning.
Yeah.
So this much of safety stock you will keep in so and so week in the upcoming. So you are designing a plan. So that's why you have the algorithm to design that plan, right? Because you have the forecast calculated, but that forecast may fluctuate because it has some errors, right? Now you want to calculate some kind of buffer stock which should not increase your inventory cost so much, and it should not underutilize also, right? So it should not create a situation of your bullwhip effect, right? It is just over it is doing at every stage. So that's why you are just calculating this kind of recommended safety stock, so that you know that how much inventory you need to pile up in upcoming weeks, so that you have the full-fledged plan for the next quarter or for next 6 months, which you can freeze, and then you can work according to that, right? So you will take some parameters like what exactly is your on hand stock already there. So that on hand stock will come from your S4 system or EC system, and uh, it will be also saved somewhere in your uh, planning system, which is IBP. So you will also consider that on hand stock is already there this much. So accordingly I should calculate uh, the future stock, right, as in terms of safety stock or the other stocks that we are seeing. So that's the overall parameter or objective of these parameters that we are discussing here, Vinod. Vinod, you there?
Yeah, I'm here. Yeah.
Okay, okay.
Yeah. I mean, I will know when you go into the systems and then how these things are getting calculated. I know the
Yeah, definitely. So what
pipeline
we'll do
calculation.
is, yeah,
Mm.
what we'll do is, yeah, we'll also, look at different scenarios. Like if we just increase this, what will be the impact? If we increase the PBR, what will be the impact, right? If we are increasing the lead times, then what will be the impact on the safety stock? So all that stuff we will see in our next class. So
Okay.
just let me know, yeah, let me know. Uh, you do you have any plans for for the next 2 days, or we can go ahead with our this time schedule for the classes?
Think I am okay. I don't know about the J.
I
Let's
have some
see.
plan actually for tomorrow. Uh,
Okay. Yeah.
Yeah.
Okay.
So Jay, what we can do is, if Vinod you are attending, I don't know about Rajneesh. He was telling maybe he may have some plan. So maybe tomorrow we will just cover up some scenarios. Maybe you can just go through the recording then, right? And if you have anything, you can always, come back. All right.
Okay.
Yeah. All right then. See you again in our next session, and we'll learn something new.